In this video recording, we're going to demonstrate some steps that you can take to convert freely available LIDAR data from, for example, maybe in this case, a UTM 15 north metric coordinate system into a regional coordinate system for use for existing ground data found in ditches and forest slopes and back slopes of roads to then be coupled with RTK GPS data for edge of pavements and shoulders that will have more precise survey elevations on them. To begin, we'll take a look at the project site area that we're working in. In this case, I have a Google Earth placemark shortcut area that we will use to locate our project site. And again, this is in northeastern Iowa, actually in Winneshiek County, along US Highway 52. And to create this polygon boundary, I used the Add Polygon tool found inside of Google Earth. And all you got to do then is give it a polygon name, and you just start to choose the locations of where you want your polygon to occur. And I use that routine to trace out this essentially this right-of-way area here inside of my screen. And what I want to do then is use that area to limit the amount of LIDAR data that we'll be bringing into Carlson software. So what I want to do then is eventually use this region inside of Carlson software. So to do that, I'm just going to right-click on my Google Earth temporary place mark here, and I'm going to say Save Place As. And I'm going to go out to a folder that I've created underneath my Carlson projects called Highway 52 IA, and I'll just create this Highway 52 IA KML file. So we've saved that KML file now out to my PC, and what we want to do then next is take a look at the LIDAR data information itself. So we'll close out of Google Earth and switch into then the Iowa GeoTree site, or the Iowa LIDAR mapping project. And in this case, the entire state of Iowa is available in LIDAR data form, and I use their web-based GeoTree LIDAR download tool, and I have that information over here on another tab. And what I've done then is I've located the tab or the grid cell of LIDAR data that I want to use. And in this case, the Iowa GeoTree site provides both LAS files for use in, for example, in like Carlson Point Cloud, and also an XYZ intensity file that is, again, a little bit more flexible for other applications. We'll use that directly inside of Carlson Civil. So I've downloaded this direct link to my PC, and again, I've also placed that out in my folder here, and I then downloaded this 7-zip file, so you can use the 7-zip file extraction utility to extract the XYZI file. That generated about a 48 megabyte text file. So as we get ready to use this data, the next thing we probably want to make ourselves aware of is the actual coordinate system information that this data is stored in. So we'll continue back into the Iowa LIDAR project metadata screen, and they indicate to us that this data is stored in UTM zone number 15, and it's also based in the metric system. So one of the things that I'm going to want to do then is take this data out of UTM zone 15 and put it into, in this case, an Iowa regional coordinate system or low distortion projection system zone that has been developed by the state. And then we'll also base that in US survey feet so that we can do our design work in a customary units that I'm more familiar with. So with this information known then, we're going to go ahead and start into Carlson 2017. So we'll browse out and we'll get the software started here. And as the software is starting up, one of the first things we're going to want to do then is indicate that we want to create a brand new drawing. So we'll click on the new icon, and I'm going to use a template drawing. In this case, I want to use a template drawing that is based on maybe the National CAD standards for survey considerations. So let's go ahead and open this up, and we'll provide the name of a drawing that I want to work in. So I'm going to go ahead and say I want to create a brand new drawing. And I'm going to go out to my Highway 52 IA North folder, and again we'll call this my Highway 52 IA drawing. And because my LIDAR data is based in metric coordinates, what I'm going to do is associate this drawing currently as a metric-based drawing, even though we're just using that as a temporary unit of measure so we can do our coordinate transformations later on. So it's going to ask us if we want to match any of our other selected unit systems. We're going to say no to this for right now. And we'll also say that this drawing is getting data that was coming in from UTM coordinate system zone number 15. We'll go ahead and choose next. And then we're going to be bringing our LIDAR data into a Carlson coordinate file. And what I'm going to do then is make my coordinate file name just a little bit different. So I'm going to say this is Highway 52, and I'll say this is a LIDAR coordinate file, or coordinate file for my LIDAR data. And normally what I'd like to do is bring in my text or ASCII file, but that would bring in the entire data set of LIDAR data that I have, and I only want to limit this to the area that was bounded by my KML polygons from Google Earth. So I'm going to say none for right now. We'll choose next. And with my coordinate system zone set, I can double check that information through my settings and drawing setup. Again, yes, we are in UTM zone 15, which is all good. So I want to bring in that Google Earth file. I'm going to go to my File menu and say Import Google Earth File. And I'm going to go ahead and just choose OK, and then grab the Highway 52 IA KML file that I had just saved out of Google Earth. So we'll do a zoom extents, and there is my KML file. And now what we'll do is we will continue with the import ASCII routine. So I'll go to my points menu, and I'll say to import my text or ASCII file into my current Iowa Highway 52 LIDAR data set. So if I say import text ASCII file, I'm going to go out and grab the 7 or XYZ I intensity file, and we can see we've got our X, Y, Z, and Z here now is in meters, so these are all meter values. So I'm going to go ahead and open this up, and I've got my format selected here for X, Y, Z, D, or in this case intensity, and I also want to limit this data to the inclusion exclusion areas that I have established on my screen, and I do not want to draw the points onto the screen. So I'm going to go ahead and just choose OK. And being prompted to select the inclusion polyline, I'll just go ahead and click on the KML polygon that came in from Google Earth. I do not have any exclusion areas, so we'll just press enter for none. And then we will go ahead and read up that 48 megabyte file and build the corresponding CRD file from that LIDAR data. Now again, with this data being in a metric system, what we're going to want to do then is ultimately convert this into a coordinate system that I want to base my roadway designs on for later on projects and discussions that will follow this video. So I've read in about a little over 34,000 points. I'll just go ahead and choose OK. And what I want to do now is convert from UTM zone 15 into an Iowa regional coordinate system zone. To do that, I'm going to go to my points menu, and I'm going to say adjust coordinates, and we're going to do a coordinate transformation. With my coordinate transformation, I'm going from grid to grid, and I'm going to say I want to get my point numbers. So, and I'm going to go ahead and overwrite the existing coordinates. So I don't need to keep the UTM's zone 15 coordinates. There's no sense in carrying that extra data around. So I'm going to go ahead and just choose OK. And we are going to then say, what is the transformation source? Well, in this case, what we're going to do is we're going to say more predefined, user-defined. And I'm going to go out and select from one of my favorites. I've got a group of favorites in here. I've got the UTM Zone 15 North already established. And I can go and grab as many of these favorites as I want in here. I can just say add predefined. And in this case, I can choose USA, or I can come down and choose any variety of different coordinate systems, and I grabbed UTM from the bottom of the list, but I'm just going to cancel that for right now. So I'm going to say my source is UTM zone 15 in metric, and my destination now is going to be my USA County Iowa Regional Coordinate System Zone 2 for Mason City, but that's going to be in US feet. So I'll go ahead and choose OK. And we'll grab all points in here, all 34,000 points, and just choose OK. And we're going to then transform that data in the CRD file directly. And then what we'll do is we'll turn around and do that exact same thing for the polygon boundary that I have inside of my drawing. So we've transformed all those points, and now what we're going to do is go ahead and we'll do the same thing for the polygon. So again, grid to grid. This time we're going to choose screen entities as the data from, and we'll just go ahead and choose OK. All my values are reestablished as what I had before. We'll just go ahead and choose OK. We'll click on the polygon boundary, and it's going to then transform it to its new coordinate location, and we will get to that location real quick by doing a zoom extents. There it is. And now that I've transformed the coordinate system zone, I'm going to also do the same thing for my drawing setup. So I'm going to go back under drawing settings, drawing setup, and I'm going to say this is now an English-based unit, and it's not UTM any longer. This is from one of my more predefined user-defined, in this case zone 2 for Mason City. We'll just choose OK. And what we should be able to do then is round trip this polygon now back out to Google Earth to make sure it falls in the exact same location. So I'm going to go to my File menu, and we'll export a Google Earth file, and we'll just choose OK on all this data in here. And I will say this is maybe Highway 52 IA regional coordinate system is my KML polygon file, just so we knew that's where it came from. And we'll pick off this polygon, and we'll see if Google Earth in fact takes us to the exact same location area. So as we zoom in to this location, you can see that yes, in fact, we do fall exactly where we're supposed to be. So we know now that our coordinate transformation is valid, at least in the horizontal sense. So the next thing we want to do is we'll take a look at some of our points, our first couple points maybe. So we'll just do a points, list points, and we'll just maybe do points 1 through 10, just to give you an idea what we're looking at in here. And you can see that we know that our horizontals are going to be okay, but our elevations are still in meters. So what we want to do now is change the elevation values of my points. To do that, what I'm going to do is go and grab the meter to US feet scale factor, and I can get that from the software very easily by going underneath my edit menu, and I can go down to scale and scale wizard. And I'm not going to use a customized scale factor here. I can say maybe I want to say my source is metric, my destination is US feet, and I have a scale factor now of 3.28083333, and I'll just go ahead and right click on that and say copy, and we'll copy that value to our clipboard. And now to convert the elevations of the points, all I have to do is go underneath my points menu. We're going to go underneath coordinate file utilities. We'll choose the elevation for points command, and we're going to say all points, and we want to apply a scale factor, and the scale factor we want to apply is, again, we'll just paste the value right in here, that 3.28083333 number. So go ahead and choose OK, and we've just converted all the points, the elevations now, and let's relist, for example, points maybe 1 through 10, to get an idea. And we can see now we've carried over brand new elevations. So ultimately what we want to do here now is make a surface model out of all this LIDAR data, and we will go ahead and do that now. So if we go underneath our surface menu, we're going to say triangulate and contour, and one of the things that we're going to do first off is give it the name of a file we want to create. So I'm going to write a triangulation file, I'm going to give it a name, and I'll call this Highway 52, and I will call this Iowa, and I'll say this is my LIDAR based model. And what I also want to do is we're going to use an inclusion-exclusion area, which is going to be this area in here, and maybe we'll limit the data, since my LIDAR data is actually pretty dense in terms of its actual physical locations from point to point. We're going to limit our interior and exterior triangulation length to no more than 50 feet. And I'm going to go ahead, and I do not want to draw contours at this point in time. And for my selection, what I'm going to do is indicate that I want to specify my selection options, get some data from the screen, and also data directly from the coordinate file that I produced earlier, and that's going to be the Carlson coordinate file here. So I'm going to go ahead and just choose OK, and it's prompting me now for my inclusion perimeter. We'll just go ahead and pick on it. I again do not have an exclusion area, and then points and break lines within the drawing to triangulate, which I don't have any, so I'll just press enter. and now the coordinate file that I want to use for my LIDAR data itself, and I'll grab the CRD file, and we'll go ahead and choose all coordinates, and we'll just choose OK. So we've gone through now and created this Highway 52 LIDAR tin surface model from data directly out of the coordinate file. And again, that helps keep my drawing nice and compact. I don't have to worry about lots of points in here that really don't carry any intelligence. So to validate my surface model, I'm going to go to my View menu, and I'm going to go to my 3D views, and we'll look at the surface file routine and look at the resulting tin from my surface model. So as we take a look at this surface model now, and we'll sort of put ourselves into an isometric view and sort of zoom in here a little bit. Again, you can see that we have some data that we can use out in the ditches and the side slopes, but in another lesson, we'll be actually going through and getting some RTK GPS data for my shoulders, edge of pavements, and center lines, and then merging two sets of surface models together to form a composite data where I've got LIDAR data for the ditches, but more precise elevation RTK data for the roadway model itself. So that concludes this lesson on how to convert LIDAR data into a more design-friendly environment using tools found inside of Carlson Civil. Thank you for your time.